Part 3 of the video is going to cover two more techniques called power series method and matrix method. First, I'm going to do the power series method. Using power series to solve. So again, we're going to do a trial solution, which is y is equal to, instead of something simple, this is going to be a bit long. So we have sum of, I don't even know how to say this, an xn from n equals 0 to infinity. Y prime is equal to, since n was 0 here, so first derivative n starts from 1 all the way to infinity, times n, we just bring down here, do a power rule, n x n minus 1. Similarly, y prime prime is equal to sum of n from 2 to infinity, n minus 1, x n minus 2. So now we can expand and basically write this whole thing into the format and the equation. So we have sum of n from 2 infinity, n minus 1, x n minus 2, plus n starts from 1 to infinity, n x to the n. There's no minus 1 because we had a x here. If I bring that, it was x here, right? If I bring that x here, is basically n minus 1 multiplied by x, and these two, they just cancel. And then we have y is n from 0, infinity, x n plus 1 is equal to 0. Yn plus 1, because I had a x there. If I put x here, like xn times x, well, this is xn plus 1. So now we're going to need to perform series addition, because what we're going to do is we're going to, instead of having 3 series, we're going to need to put one big series. We're going to combine them into a one big long series. But before we can do that, two conditions must be satisfied. First, to be able to do series addition, first, the power of all the series here, here, here must be the same. Second condition, their starting value or starting index must be the same. So now we're gonna use k to adjust that. So for first, now also need to know that when do we need to use k, because we have 3 series from 0, from 1, from 2. Anyway, let's just do this, and I'm gonna explain every single step at a time. So for series 1, we say k is equal to, like, we make k whatever we have here, this. For each individual series, we make k is equal to this power, this power, this power. So in this case, k is equal to n minus 2. That means my n is equal to k plus 2, and starting value was k, n equals 2. So when n is 2, my k is 2 minus 2, 0. That means this series 1, is gonna start from k equals 0. Series 2 we let k is equal to n, and well, since they're the same, when n equals 1, k is 1, right? For the third series, we let k is equal to n plus 1. That means n is equal to k minus 1. So when n is equal to 0, k is equal to 1. Right? Because n is 0, 0 plus 1 is 0. 0 plus 1 is n, is 1. Now we gonna replace odd n by k. So for the first series, we have n equals 2, right? We're gonna say k equals 0 because n equals 2 is the same as k equals 0. Infinity, when you see n is this. So k plus 2 and then n minus 1. N is k plus 2 minus 1, k plus 1. A n minus 2. Wait, hold on. N is k, so this is n, this is k, n plus 2, sorry. Because n is k plus 2 times x to k. There's no n plus 2, it's k plus 2. I'm a bit tired. And then my second series starts from 1. And since k is equal to n, so just replace n simply by k. And my third series, we have starting value is k equals 1. Whenever you see n, replace by k minus 1 equals 0. Let me just double check. Okay, seems good. Now, we just satisfied the first condition. We made all the power to be the same, which is kx to the k. However, we still have different starting index, right? Here starts at 0, the other two starts at 1. So what we're gonna do is we're gonna factor out the first term from the first series, and the other two, we can say it's good. Good means no changes need to be made. The reason why I factor out the first term from the first series is because if I factor that out, then k can start from 1, right? It's a series that if you factor out something, then the starting index is plus 1. So all the series will start from 1. So we're gonna factor out the k is equal to 0 term, meaning we're gonna sub k equals 0 in this expression, this whole expression. So 0 plus 2, 0, 0 plus 1, 1, 2 times 1, 2, times a, k plus 2, 0 plus 2 is 2, times x to the 0, which is 1. So we have this. This is for k equals 0, right? And now we can combine all the series. Plus, the series are now starting from k equals 1 all the way to infinity. We have we also have the common term x to the k, x to the k, x to the k. So we can do x to the k k plus 2, k plus 1, a, k plus 2. This is from series 1. Add the second series, k, ak. This is series 2, and then the third series we have k, a, k minus 1. Now we say that this whole thing is 0. What does that mean? That means my constant term, this is the constant term, and the series, they must be 0, because 0 plus 0 is 0. So we have constant term equals 0. That means my 2a2 is 0. That means my a2, the second term, is 0. And then we also have the series. However, we're going to call it coefficient equals 0. What is coefficient? Coefficient of what? Coefficient of x to the power of k. And that is this whole thing is equal to 0, because this is the coefficient of x to the k. So that means k plus 2, k plus 1, a, k plus 2 plus k, ak plus a, k minus 1 is equal to 0. Now, something very important we're going to know here is that we're going to need to get a recurrence relation. Recurrence relation is a relationship between the current term and future terms. What does that mean? That means if you look at the current terms, like currently I have this term, and then if you have the recurrence relation, then you can predict the future terms. So it's basically the relationship between future and current. So that means you're gonna isolate the future term. And what is the future term? It's the term that has the biggest k. We have a, k plus 2, a, k minus 1. Which one is the future term? Which one is the latest term? The latest, the term that comes the latest is the future term, which is this guy. So we're gonna isolate this. Is equal to, we have just simply put this 2 to the other side, k, ak plus, minus k minus 1 divided by k plus 2, k plus 1. And this is my recurrence relation. So now I have a2 to be 0, and I also have a k plus 2 to be 0. Don't forget that in the first step, we say that my y is equal to sum of n 0, an, xn. Expand this, what do we have? We have when n is 0, a0, x to the 0 is 1, plus when n is 1, a1, x plus a2x squared plus a3x cubed plus a4x to the 4 plus ... This is what it looks like if we expand y, right? So this is kind of our general formula. So now we have a0, a1, a2, a3, a4 all the way. We're gonna need to know the values of them. So we have a0, we also have a1. Since we never had anything about a1 and a0, that means these two terms are arbitrary, meaning whatever the value, they can be whatever the value you want them to be. And the first value we find is actually a 2, which we said is equal to 0 here. And starting from a 3, we're going to use the recurrence formula here. If you look at this a3, right? Because we do this in the increasing order: a0, a1, a2, a3, a4, a blah 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 blah. Now we have a3. What is this? K plus 2. So k plus 2 is equal to 3. That means my k must be 1. For k is equal to 1. So now we're going to sub k equals 1 into my recurrence relationship. Let's use a different color. K equals 1. So we have minus a1 minus a1 minus 1, 0. Divided by k plus 2. 1 plus 2 is 3 times 1 plus 1, 2. So this is basically 6. a1, we said it's arbitrary. Minus a0, which is also arbitrary. Well, we're going to leave as it is. Or I can just say it's kind of arbitrary because we have 2 arbitrary value divided by 6. Now we have a4, meaning k is equal to 2. Why is k equal to 2? Because here, this must be 4. So 2 plus 2 is 4. So I'm going to update this, my scratch. So k is now 2. So we have minus 2, a2 minus a2 minus 1, 1 over 2 plus 2, 4 times 2 plus 1, 3. So this is divided by 12. We say that a2 is 0 here. So this is gone. Negative a1 divided by 12. Next, we have a5. K is 3. Update this. When k is 3, we have minus 3, a3 minus a2. Divided by 3 plus 2, 5, times 3 plus 1, 4, so that's 20. So we have this expression, and we say a2 is 0, so this is gone. We have minus 3 over 20, a3, right? Now let's do, I don't know how many we're gonna do. Usually the question for this type of question, asks for find me the first 8 non-zero terms. How many non-zero terms we have? We have already 2 arbitrary. This is good. A3 is good. A4 is also good. A5 is also good. So we have 3 plus 2, 5 non-zero terms. So far, let's do more. A6. This is for k is equal to 4. So minus 4, a4 minus a3. 4 plus 2, 6 times 4 plus 1, 5. That's divided by 30. So we have this relation. How about a7? Let's do one more. This is k is equal to 5. What do we have? So when k is 5, we have minus 5, a5. I'm basically looking at this. Minus a4. 5 plus 2, 7 times 6. That's 42. If the question asks for, I don't know, 1, 2, 3, 4, 5, 6, 7. If the question asks for 7 non-zero terms, we already have them. So we can write y is equal to what? That's why I wrote this earlier. Where is it? Here. I'm gonna use this. So a0, well, arbitrary, copy that. A0 plus a1 x, a1 is also arbitrary, x plus a2 x squared, a2 is 0, so well, just say it, plus now we have a3 x to the 3, a3 is this, plus a4 is this, don't forget this is x to the 4 plus a5 x to the 5 plus a6 and finally a7 plus dot dot dot. And there you go. Is this question kind of hard? No, but it's kind of easy to make algebra mistakes. And when you're making the series, when you want them to be able to be combined together, you're gonna make sure the starting, the power of x are the same, which we made them equal to k. After we made them to k, we're gonna make the starting index, which is this value, to be the same by adjusting. This is what we do here, this step here, right? So I also need to factor out k equals 0 because we see that k equals 1, k equals 1 for the other two series. So we're gonna bring the first term out from the k equals 0 series. Why this one is because if we bring the first term out, then the next term is gonna be k equals 1. So, and then we are able to combine the three series together into this one long series. And now we're gonna say that since this plus that is equal to 0, that means my constant is 0, 2a2 is 0, a2 is 0, and the coefficient of x to the k must be 0. That means this must be 0. Once we say that this is 0, we need to find the recurrence relation. Again, the recurrent relation means use the current term to predict the future term. So we isolate the future term, and the future term is the one, it's the a that is largest k. In this case, we have k plus 2, ak minus 1. The largest one is definitely k plus 2, so we isolate this, and then we have this to be our recurrence formula. And then we can, well, this step is optional, but it's good to write it down to remind yourself what the equation, what the final equation looks like. And then next, your job is to find the value of a0, a1, a2, a3, a4, all the way to, if the question asks for the first 5 non-zero terms, then you need to find 5 non-zero out of a. A1, A0, they're arbitrary, R2 non-zero, A2 is 0 because we found that the constant is 0, so A2 is 0, and then just keep finding the k value, the A value until it is not 0. There you go, and then you can assemble this. It looks kind of ugly to me, but this is correct. The last topic we had in the course ENGEA 213 was called matrix method, and this one is really a bit annoying. I'm gonna say it's not super long, but if you ever had the last case, the two complex roots case, it is very nasty. What is the matrix method? Well, question is going to tell you that use the matrix method to solve this equation, so no worries if you cannot identify it, but it is really a no-brainer to identify this type of question is you see that are systems of equations. What do I mean by that is, how about we just solve one? We have dx dt. Basically, we have multiple equations, then this is a hint that you're going to use this method. This is an example from the book. Okay, so the question is this. Solve this. So the first thing is we gonna need to write A. What is A? A is the 2 by 2 matrix, is equal to basically the coefficient of here. So coefficient first row is 1 and 2. For second row is 4 and 3. Now, first step is to get the eigenvalue lambda. It's obtained by using this equation, determinant of A minus lambda times I being the identity matrix. Identity matrix is whatever, let's say if you have a 2 by 2, then 1, 0, 0, 1. If you have a 3 by 3, then it's like this. The diagonal being 1, 1, 1, and all the other entries being 0. This is the identity matrix. So what is A minus lambda I? It's simply we put a minus lambda this to the diagonal. That's it. So let's look at it. We have determinant of 1 minus lambda, just the diagonal. So 2 doesn't change, 4 doesn't change, 3 minus lambda, set it equal to 0. Find the determinant of this. We have 1 minus lambda times 3 minus lambda minus 8 is equal to 0. So we have open this up, right? We have 3 minus 4 lambda plus lambda squared minus 8 is equal to 0. We are just looking for the value of lambda, just like in previous steps, we're looking for the value of m when we're using the trial solution. In this case, we use lambda. So this, we have lambda squared minus 4 lambda plus, minus 5 is equal to 0. So we have lambda plus 1, lambda minus 5. This tells me that lambda 1 is equal to minus 1, lambda 2 is equal to 5. Now, next up is to get something called eigenvector. I have no clue why it is called eigenvalue and eigenvector, but eigenvalue is simply lambda, and this is the method of how to get this value. Eigenvector is the relationship between k1 and k2. What does that mean? No worry, let's proceed. Step 2, eigenvector. Now for lambda 1 is equal to negative 1. what do we have here? We're gonna need to do the same thing. We have a minus lambda I times k1, k2 is equal to 0. This is where you see k1 and k2, right? I mentioned here. And k1 and k2, they're like a vertical, what's it called? 2 by 1 vector. So a minus lambda times I, what is that? A is this, and we have minus lambda I. We just simply minus this value at the diagonal entries, right? So we have 1 minus 5, 1, 1 minus minus 1, 2, 4, 3 minus minus 1, k1, k2 is equal to 0. This is actually not a number 0, but like the 0 matrix. 0. 0 matrix. So this we have 2, 2, 4, 4. k1, k2 is equal to 0. Now, eigenvector, I think I just said it again. I just said it before. Eigenvector is the relationship between k1 and k2. What does that mean? That means if you perform, basically we're looking for a value, any arbitrary value, but simple value for k1 and k2, right? We need to find a value for k1 and k2 such that this two multiplied together is equal to the 0 matrix. Let's use row 1. So we have 2k1 plus 2k2, this times that, plus this times that, is equal to 0. What does that mean? Divided by 0, divided by 2 from both sides, we just have k1 is equal to negative k2. And personally, I prefer to write a short if statement. If whatever the value we want for whatever the k we have, if let's say k1 is 1, if k1 is 1, what is k2? Then k2 is equal to negative 1. So my k1 and k2, the first eigenvector, is simply 1 minus 1. Now we can do for lambda 2 is equal to 5, right? That's the other eigenvalue we just found for lambda equals 5. Then we have 1 minus 5, 2, 4, 3 minus 5. k3, k4 is equal to 0. This is like minus 4, 2, 4, minus 2. k3, k4 is equal to 0. Again, we can use which row we want. We can use this first row. So minus 4 k3 plus 2k4 is equal to 0, or I can say that is equal to minus 2 k4. Right? So this simplifies into divided by minus 2 both sides. So we have 2k3 is equal to k4. We say if k4 is equal to 1, then k3 is equal to 1/2. Or you can say, let's do the simple way. If k3 is 1, then my k4 is 2 times 1, is 2. So my k3, k4 is equal to 1 and 2. Now you can choose this value whatever you want. You can choose this to be, I don't know, pi, and then just need to find k4 according to pi using this relationship. Because I said the eigenvalue, the eigenvector is a relationship between the two k's. You can say that's a sine of 0.812 times e to the pi times 10 psi, right? You can choose this value to be k3 to bother whoever is grading your paper, to drive that person crazy, but make our lives easier by choosing a very simple value, 0, 1, 10, those integers, and then you get a relationship. Basically, this eigenvector is like all of the eigenvectors, they are like parallel to each other, but varying in magnitude. Let's say this vector versus this vector, well, they have the same direction but different magnitude. That's how you choose this value. If you choose 10, then this is 20. That's like a short versus long vector, right? So now we have two eigenvalues, two eigenvectors coming from the two real eigenvector situations. We can plug into this equation. So we have x to the t, big X is equal to c1 v1. v1 is my vector 1, which is my first v is vector, which is my eigenvector. So 1 minus 1 times, it's been a while, I forgot, e to the lambda. Lambda, this is for lambda equals -1 plus c2 v2, or vector 2, the other vector, e, and this was for 5, right? Okay, so for the second case, let's do an example which yields one single root for the eigenvalue lambda. So we have the matrix A is equal to 3, -1, 9, -3. So first step, eigenvalue lambda is equal to determinant of a lambda I is equal to 0. So we have 3 minus lambda minus 1, 9 minus 3 minus lambda is equal to 0. So we have 3 minus lambda times -3 minus lambda plus 9 is equal to 0. I have -9, -3 lambda plus 3 lambda plus lambda squared plus 9 is equal to 0. 9 and -9 cancel out. Minus 3 lambda plus 3 lambda cancel out. And lambda, I have 0, which is, don't panic, getting 0 is kind of normal. It is a real root, right? Because 0 is a real number. It's not a complex. So now we get step 2, eigenvector lambda is equal to 0. What do we have? We have the same thing. 3 minus 0. Don't bother writing it. Copy the matrix. We have k1, k2 is equal to 0. Let's take first row. 3k1 minus k2 is equal to 0. 3k1 is equal to k2. What does this mean? This means if I personally I prefer writing this small if statement. If k1 is equal to 1, then my k2 is going to be 3. So my k1, k2 is going to be 1 and 3. Now, how about the second eigenvector? Because we need 2 eigenvectors. Why? Let's look at the template we have here. This is for the single root here, sometimes called repeated root. We just find the first vector. This vector is used again in the template. However, what is this w? This w is basically a second vector. So now let's see how we get the second vector, or let's say the other vector w. How do we get that? W is obtained from this equation is always a minus lambda I, right? Multiplied by W1, W2 is equal to K1, K2. So we can just copy A. We can only copy A because in this case, my lambda was equal to 0. If lambda was something else, then it's not just simple as copying A. Is equal to what we just found, 1 and 3. Again, we can use first row. 3 W1 minus W2 is equal to 1. We can isolate W2, right? W2, put it to the other side and bring 1 to the other side is equal to 3 W1 minus 1. And now we don't have anything to plug in, right? So how about we say W1 is arbitrary. And arbitrary value includes 0. That means when W1 is 0, that gives me W2 is equal to -1. So my W1, W2 is 0. Oh wait, which one is 0? W1 is 0. And don't mix this two, huh? Don't mix this value up. It's not 1 and 0. Pay attention which one you choose to be 0, which one is non-zero. This is not 1, this is -1. Because 3 times 0 minus 1 is W2. Again, we can plug everything we just found into the template value template equation. This is the template equation: C1 E lambda T V plus C2 E lambda T times Vt plus W. So we have C1 E lambda was 0, 0, so this is basically 1 times V. V we found, this is my V. V stands for vector. 1, 3 plus C2 E lambda T is gone because it's just 1. I have 1, 3 times T plus W just found 0, -1. Voila. You can introduce T inside, but I'm just too lazy. Okay, the third example is the third case where we have the ugliest situation, which is we got a complex form for eigenvalue lambda. We have 2 complex roots. It's not because it's hard, it's just because the template equation it's too long, and if you forget what it looks like, then your question cannot be solved. So the whole thing about this course, ENGR 213 ODE, is I put a huge chunk of time to memorize all those template equations, right? Before, for first order differential equations, we have Bernoulli, we have linear, exact, non-exact, blah, blah, blah. All those techniques, there's a unique method, there's a unique structure, unique template. For second order, same thing. For power series, for matrix, there's a unique structure. And in one of the procedures, in one of the steps, you may need to memorize the unique template equation. So that's what makes this course a bit hard. So again, we have eigenvalue lambda is obtained from determinant of a minus lambda I is equal to 0. So we have 6 minus lambda minus 1, 5, 2 minus lambda is equal to 0. We have 6 minus lambda, 2 minus lambda plus 5, because minus 5. So we have 12 minus 8 lambda plus lambda square plus 5 is equal to 0. And this is like lambda square minus 8 lambda plus 17 to be 0. Now, using quadratic formula, lambda is equal to 8 plus or minus 64 minus 68 by 2. So we have a plus or minus 2i over 2, because square root 4, right? This is like 4 plus or minus I, with alpha equals 4 and beta equals 1. Now we do eigenvector. We have, again, same thing, lambda I k1 k2 is equal to 0. But the thing is, which lambda we're gonna take? We have a plus or minus, right? So by default we do plus. So we have the first entry, we have 6 minus lambda, so 6 minus 4 plus lambda, so 6 minus 4, 2 minus lambda, minus 1, 5, and then we have 2 minus the same, which gives me minus 2 minus lambda. Let's say first row, what do we have to get a eigenvector? We have 2 minus I k1 is equal to k2. So if k1, let's just do 1, then my k2 is 2 minus I. So k1 and k2 equals 1 and 2 minus I. This is the same thing as 1 plus 0i, 2 minus 1i. We're gonna put a real part together vertically and imaginary part together vertically. This is my real, this is my imaginary, right? Now we can plug in into this whole, this is very long template equation here. I don't even want to write it down again. Let me just copy it. we have e to the alpha t. Alpha, we just found 4, beta to be 1. This real is not an English word. It's a vector, which is this. And the im is imaginary vector here. So put everything together, we have the first vector we found. No, not the first one. The real one is 1, 2 cos beta t. Beta was just 1, so cos t minus imaginary 0 minus 1 very long. Can do an optional one more step, which is write this whole thing as a vector form by distributing the cosine, the sine into the parentheses. So we have top row, we have simply cos t. Bottom row, we have 2 cos t minus minus plus sine t. I'm basically putting cos inside into the first row, into the second row, first row, second row. Similarly here, top row I only have sine t, bottom row I have 2 sine t minus cos of t. Now let's do this example, which is non-homogeneous because we have another term in the end. We call it f of t, right? So this can be done by using undetermined coefficient inside the matrix method, right? First step, the entire course, like the entire second order or whatever is after the second order differential equation, basically everything's midterm. The first step never changes, which is to solve this equation as a homogeneous equation, meaning the right hand side equals 0. So let's go. Now, what is A? A is this, and this is my f of t, which is dealt with in in the particular solution. Again, this is a complex case, the third case, the ugliest case. So now we do eigen the vector and we're gonna take the positive form Now we have so from row 1, we can do row 1. We have -1 minus I k1 plus 2 k2 is equal to 0. Or if you bring this to the other side, right? That means negative of this is equal to 2k2. And then my k2 is equal to and this, by the way, this can be distributed in, so I have 1 plus I over 2 times k1. Now it's going to be simple if I say if k1 is equal to 2, then my k2 is 1 plus I. So my k1, k2 is k1 is 2 and k2 is 1 plus I. Remember, this can be written as 2 plus 0i, right? So this is equal to 2, 1 being my real vector plus 0, 1, I being my imaginary. So now my xc is equal to e to the alpha. Alpha was 0, so there's no e. Now our xc is done. What we're gonna need to do is find xp, the particular solution. Like I said before, most likely we're gonna use undetermined coefficient. So let's analyze the f of t here to make an educated guess. We see that there's only number there, so it's gonna be a and b. Simple as that. And we're gonna need to find x prime so that we can write into this equation, into this format. We just find x to be a and b, and we need to find x prime, which is 0, 0. So we're gonna put everything together with x prime on the left hand side is equal to a times x plus f of t. Now we're gonna do this separately. We have row 1 and row 2. Row 1, I have 0 is equal to minus a plus 2b minus 8. And row 2, I have 0 is equal to negative a plus b minus 3. Now the job is to find the value of a and b. Let's do row 1 minus row 2. This is like Gaussian elimination. So we have 0 is equal to minus a minus minus a gone. 2b minus b is just b. And minus 8 minus 3 minus 11. So my b is 11. And then we can plug b into any of the equation. We got a to be 14. Right, we can do it here. So 11 plus 3, that's positive 14 minus 14, that's 0. So we just found a and b by using undetermined coefficient. My xp is therefore 14, 11. And in the end, my x of t is equal to xc plus xp, right? Is this whole thing plus 14, 11. There you go. Okay, the last example I'm going to do is this. Again, this is my f of t. We're going to use, the idea is pretty much the same thing. Find the complementary solution, find a particular solution for xc is going to be one of the 3 cases. You just forgot that you don't have, again, the complex case because it's really long, and then use undetermined coefficient to solve f of t. So now we do that a minus lambda identity is equal to 0. So we have that gonna solve this. So we have we have 18 minus 9 lambda plus lambda square minus 4. So we have lambda square minus 9 lambda minus 14 plus 14 is equal to 0. Lambda is gonna be, nope, minus 7 minus 2, right? That's positive 14, add them up, negative 9, so lambda 1 is 7, lambda 2 is 2. Okay, so we have a 2 real roots case. Eigenvector for lambda equals 7, we do a minus lambda I k1 k2 to be 0. So we have when lambda is 7, we have this minus 7, this minus 7, negative 1, and negative 4. We can take row 1. We have k1 is equal to k2. right? Because negative k1 plus k2 is equal to 0. Bring plus k2 to the other side, becomes negative k2, cancel out the negative. That means my k1, k2 is 1, 1. I just didn't write an if statement because, well, the ratio of k1 and k2 is 1, 1. If k1 is 1, k2 must be 1. For lambda equals 2, we have 6 minus 2, 3 minus 2. So we have negative 4 k3 is equal to k4, because this was like 4k3 plus k4, right? I put k3 to the other side, so I have that. That means if k3 is 1, then my k4 must be negative 4. So my second eigenvector is 1, negative 4. Therefore, plugging into the template for the case where you have two real eigenvalue, this thing is equal to C1 E7T 11 plus C2 E2T 1 minus 4. Now we're gonna need to deal with x of t. xp, sorry, particular solution. Look at what we have here. We have 6t and minus 10t plus 4. We can use the same, we can borrow the same table from the undetermined coefficient to make the educated guess. So my top row is going to be at plus b. And my second row, another polynomial, so ct plus d. The derivative of this is ac vertically. So now we put everything together and write it in this form. The derivative is equal to ax plus f of t. What is a? 6143. And my f of t, 6t minus 10t plus 4. Now our job is to find the value of a, b, c, d. Okay, so let's do row 1, or top row. A is equal to distribute this into that, distribute this into that, 6at plus 6b plus ct plus d plus 6t. Row 2 got c is equal to 4, distribute that, 3, distribute there, 4 at plus 4b plus 3 ct plus 3d is equal to 9, no, net minus 10t plus 4. Now we can make a table. Like, this is exactly the same technique that we use in undetermined coefficient. Treat these two kind of separately. We can say for row 1, we're gonna make a table. We have basically here what we can do is the trig is a plus 0t, c plus 0t. So what we have is no t or 0t. We have what? We have no t, this term, right? There's no t inside, so 6b plus d, and with t, we have, no, sorry, no t is like a, this a is equal to 6b plus d, and then we have t, which is 0, because we just say the green color 0 is equal to 6a plus c plus 6. Let me double check. Okay, and for row 2, again, we have no t and t. No t is c is equal to 4b and 3d plus 4. And t, we have 0 because this 0t. 0t, so 0 is equal to 4a plus 3c and minus 10. Now we can solve this 2 equation first, because we have only a and c together. We have 2 equations, 2 unknowns, right? Because we can't solve the top 2 because we have 2 equations, 4 unknowns. Bottom, the 2 equation that's equal to 0, we have pure numbers and 2 unknowns, 2 equations, so we can solve this. So from this guy, I'm gonna call it equation 1, equation 2. From row 2, we have, no, wait, hold on. From this one, we have c is equal to minus 6a minus 6, right? We're gonna sub this into this one. So we have 0 is equal to 4a plus 3 times, so negative 18a plus 18 minus 10. So we have minus 14a. This is 8. Wait. This is not plus. This is minus, right? Because it was plus 3c. Yes, plus 3c. So it's going to be minus here, not minus minus. So no plus. Is equal to 28. Yep, minus 28. Put it to the other side, 28. So a is negative 12, and c, I'm gonna get minus 6 times minus 2 minus 6, so 12 minus 6, equals 6. Once we have A and C, guess what? We just unlock A and C. And we have only B, D, two unknowns in the other two equations, so we can solve. So now we basically have the first one, A is equal to 6B plus D. A, we found it to be minus 2 is equal to 6B plus D. The other one, C, is 6 is equal to 4B solve this. Gonna cut the steps. B is equal to minus 4 over 7, and D is 10 over 7. So in the end, if you put xp, the particular solution, xp is this. At minus b, right? And ct plus d. So the final x is xc plus xp. We have this. Plus this. And if you really want to make this look a bit nicer, you can put a t here, so this can be written as right? And there you go.